Hi, welcome back to my chemistry channel. Today I'm going to talk about substituted hydrocarbons and their reactions. First, we're going to talk about functional groups. A functional group is an organic molecule, is an atom or group of atoms that always react in a certain way. The addition of a functional group to a hydrocarbon structure always produces a substance with physical and chemical properties that differ from those of a parent hydrocarbon. Organic compounds containing several important functional groups are shown in the table above. Organic compounds containing halogens. There is any organic compound that contains a halogen substituted is called a halocarbon. If you replace any of the hydrogen atoms in an alkaline with a halogen atom, you form an alkyl halide. An alkyl halide is an organic compound containing a halogen atom covalently bonded to an alphabetic carbon atom. And properties and uses of halocarbons. It is easiest to talk about properties of organic compounds containing functional groups by comparing those compounds with alkalis. Substitution reactions. One way is to introduce a functional group through substitution. A substitution reaction is one in which one atom or a group of atoms in a molecule is replaced by another atom or group of atoms. With alkalines, hydrogen atoms may be replaced by atoms of halogens, typically chlorine or bromine, in a process called halogenation. One example of a halogenation reaction is the substitution of a chlorine atom for one of ethane's hydrogen atoms. Our next awesome topic is alcohols, ethers, and amines. Alcohols. This is our first main subtopic. Many organic compounds containing oxygen atoms bonded to carbon atoms. Because an oxygen atom has 6 valence electrons, it commonly forms 2 covalent bonds to gain a stable octet. An oxygen atom can form a double bond with a carbon atom, replacing 2 hydrogen atoms, or it can be formed from single bond with a carbon atom and another single bond with another atom, such as hydrogen. An oxygen-hydrogen group covalently bonded. As we are speaking about alcohol, there's another type of alcohol called denatured alcohol. It's ethanol to which small amounts of noxious materials such as aviation gasoline or other organic solvents have been added. Ethanol is denatured in order to make it unfit to drink. Because of their polar hydroxyl groups, alcohols make good solvents for other popular organic substances. Our next awesome subtopic is ethers. Ethers are another group of organic compounds in which oxygen is bonded to a carbon. An ether is an organic compound containing an oxygen atom bonded to 2 carbon atoms. Ethers have the general formula ROR. Since ethers have no hydrogen atoms bonded to the oxygen atom, their molecules cannot form hydrogen bonds with each other. Therefore, ethers generally are more volatile and have much lower boiling points than alcohols of similar size and mass. Our last and amazing subtopic is amines. Amines contain nitrogen atoms bonded to carbon atoms in aliphatic chains or aromatic rings and have the general formula RNH2. Our third and last awesome topic is carbonyl compounds. These carbonyl compounds have organic compounds containing the carbonyl group. The arrangement in which an oxygen atom is double bonded to a carbon atom is called a carbonyl group. These groups. Then we have ketones. A carbonyl group also can be located within a carbon chain rather than at the end. A ketone is an organic compound in which the carbon of the carbonyl group is bonded to 2 other carbon atoms. Ketones have the general formula. Our next subtopic is carboxylic acids. A carboxylic acid is an organic compound that has a carboxyl group. A carboxyl group consists of a carbonyl group bonded to a hydroxyl group. Our last and amazing subtopic is the organic compounds derived from carboxylic acids. Several classes of organic compounds have structures in which Then we have an amide. This is an organic compound in which the OH group of a carboxylic